Great to see everybody. My name is Bruce Momjian. I have one of the Postgres core team members, and I've been working for Enterprise DB for 16 years, which seems like a long time, but hey, it's where I fit, I guess. I'm here to talk to you about security. The slides that you're going to see today are at this URL right here. So as I mentioned in the keynote, there are 58 presentations here, over 100 videos, and 650 blog entries, which the person from Timescale was kind enough to mention. So a lot of interesting information there. This presentation, if you see Magnus Hagender out there, some of the ideas originally came from him. I believe it was a talk he gave, I want to say in 2008 in Portland, Oregon, or Seattle. I don't remember which. He may remember. But he always reminds me that I took some ideas from him, so I always keep the name there because I like to give people credit, and I wouldn't have thought of some of the things had he not sort of made me start thinking about security. Security obviously is a really complicated topic. If you go to that website there, there's a tab about security, over 300 slides about security, from the mathematics of cryptography, public key cryptography, TLS, application security, cryptographic hardware, all the way up to using it in Postgres and other applications. So if you want sort of a round tour of cryptography from the bottom to the top, that's also a URL you can go to. But what we're going to talk about today is specifically Postgres security, and specifically Postgres security related to external attack. Because a lot of people, and myself included until I wrote those 300 slides, kind of approach security. I don't know if it's like you, but I've been in the industry, database industry, since 1990, and I really didn't. I can't say I fully understood security. Yeah, okay, there's hashes, and there's one-way encryption, and public key encryption, and symmetric encryption, and there's TLS, and there's certificates, but every time I talk about it, I didn't fully understand exactly what it was we were doing. So fortunately, my employer, a couple years ago, I said, we really need somebody on the Postgres team who's dug into security all the way down to the mathematics. And he said, fine, just take a couple months and read some books. And that's exactly what I did. Came out 300 slides later and was able to basically present this talk and to really dig into the security, not just from a checkbox perspective, but to actually understand what are the threats, how do you correct the threats, right? How do you make sure that you aren't. A lot of times people think, oh, if I just do X, my security problems are over. Not really. It doesn't really work that way. You have to really understand kind of what you're doing. And a lot of people, unfortunately, don't, and they just kind of check box the security. Oh, I got this, I got that, I'm done. But what this talk is to try and break that down and work through the actual things that are protected here so that your systems can be more secure. The other nice thing is we've got 50 minutes. So I'm going to be stopping, taking questions. We're going to walk through a lot of this stuff. If you're confused about something, we have time to talk about it. Unlike my keynote, where I had 20 minutes to go through this many slides, now I have 50, and it's really interesting to get your questions, okay? Any questions before we get started? Okay. So what are we going to talk about? We're basically going to talk about external attack vectors, like how do people attack the database, and how can you prevent it from being compromised. External attack vectors can relate to how security is set up. It can relate to how we set up passwords or authentication theft. It can be something like network snooping. We're going to talk about that. We're going to think about how the network communication happens between the client and the database. It can be something called spoofing, which is different than snooping, okay? And we're going to talk about how to protect against that. And then to finish up, we're going to talk about some larger issues like backup theft and administrative access, okay? Okay. What are we not going to cover? So again, we have to have a limited scope of what we're doing. What we're not going to cover are internal attacks. These are cases where somebody already has access to your database. You've given them access, you've authorized them, and then they've somehow increased their access. I'm not saying this is not important. It just isn't what I'm going to cover in this talk. Okay? Things like application vulnerability, SQL injection, database object permissions. Yes, these are important. But again, it's outside the scope of what I wanted to cover. All right. So let's talk about authentication security. And what I'm going to do is I'm going to start very simply, and I'm going to work my way up to more and more secure solutions when we eventually come to a solution which pretty much closes all of the possible attack vectors. Now, you may not want to go this far. You may decide these other vectors are not important to me, but you should understand what vectors still exist if you decide to allow certain attack vectors to be unprotected, right? If that makes sense. The other thing is that the Postgres documentation is very good about this. I've worked for several years, actually, and sort of trying to improve that. So again, if you go to the Postgres docs, it will give you similar training about how to look at this, okay? So let's start with a very simple case, and that is the connection control. So the connection control file is called pg_hba.conf. HBA stands for host-based authentication, and it effectively sets up a way of specifying what type of connections can happen to what databases for what users from what IP addresses and how do we authenticate them. Now this file, if you install from source, is going to be what you're going to get. And this is in many ways very simplistic and unacceptable, all right? It's fine for a development machine where you're basically saying no one outside can connect to this machine, and I'm happy with anyone who does have access to this machine to connect to this database using typically localhost or Unix domain sockets, okay? No, nothing wrong if that's what you want, but again, that may not be what you want. You may need something more sophisticated. So let's take a look at how one of the authentication methods is the password authentication method. Many of you may have heard of the password authentication method. It is actually a pretty poor method to use for authentication, particularly if you're not encrypting the traffic with SSL, okay? Because effectively what would happen is that you have a client who makes a connection request, and the server will actually basically say, I need a password, and the password will be sent back in clear text. Again, assuming we're not using SSL or TLS, clear text back to the client, okay, to the server. Is that a problem? Maybe, maybe not. You might be on a secure network. You might be in an environment where that's not an issue. But if you have other people, unauthorized people, who can see network traffic, and if you're aware, TCP/IP by default is pretty much in clear text, they're going to be able to use that password that they saw sent and replay it to connect a later time. All right? So this would be like a replay attack. And again, vulnerable to snooping. Yes, we encrypt it when we store it in the database, but that's not maybe sufficient, okay? Because we've passed that clear text password, or at least we haven't, in this case, we've literally passed the clear text password. So some of you may say, okay, that's bad, so I'm going to use MD5. So MD5 is going to solve my problems. It's not, but that might be what you think, okay? So you say, okay, I'm going to use MD5. Okay, so we send, the database comes back and says, I want MD5, and I'm going to give you a random salt, and the database client will return a random salt, and the random salt will then help to prevent that password from being reused, because effectively that password salt is going to change every time you connect to the database. Okay. However, the problem is that the salt is actually, for MD5 in Postgres, is only a 4-byte integer. So that means there's basically 4 billion possible salts. Any of you who have studied mathematics knows the birthday problem. What is the probability that two people have the same birthday in a room? It is surprisingly low. I'm not going to go into why that is, but effectively the birthday problem actually happens here. And it turns out within about 16,000 comparisons, you are now ready to, or 32,000 comparisons, you actually start to duplicate, your salt, and then you kind of can replay the salt because you got the salt that was used. So not a great solution. Again, we designed this back in the early 2000s. It was a great, maybe at that time, most of our systems didn't have 8-byte integers, right? We're back in the Stone Ages. So again, it was good for what it was, but certainly not today. So Postgres 10 started with something called SCRAM. How many of you have heard of SCRAM before? Good. Okay, so SCRAM, Peter, do you remember what SCRAM stands for, anybody? Thank you. Perfect. That's wonderful. I forgot. And Simon Riggs actually was also very instrumental in getting this into Postgres 10. So SCRAM is basically a way of doing what MD5 does, but in an industry standard way and in a much longer salt way, so you can't replay. Okay, so think of what we're doing with the random salt, extrapolate that out to an industry standard, and make the salt much larger so there's no replay potential. That's effectively what we have in Postgres 10. So most people, when Postgres 10 and forward are no longer using MD5, they're effectively using this new SCRAM method. What's really interesting is in Postgres 13, you actually have something called channel binding. And I can go into a little bit of this, but what channel binding effectively does, it allows the two endpoints to prove that they know the password. So it actually eliminates one of the sort of man-in-the-middle attacks we'll talk about later. I'm not going to go into that right now. But again, SCRAM with channel binding is sort of SCRAM with like superpowers in terms of preventing man-in-the-middle attacks, which we're going to talk about in a minute. Okay. Any questions? Okay, great. Okay, so let's look at what SCRAM looks like. This is the standard, and again, here it is. Salted challenge response authentication mechanism. There you go. Salted, yeah. Kind of cool. Anyway, I just know I did not set you up. I forgot that URL was there. When you use SCRAM, you're effectively getting the connection request. It's saying I want SCRAM. So the client sends a username and then a number used once, so like a random number, pretty long one. And then the server sends back the same number that it received, and then a server random number, and then the salt. And then the client sends back the client nonce that got up here, and then the server nonce, and then a client proof, which effectively mixes the certificate data with the password and proves that when we mix the password and the certificate data together and we give it to the other end, we're proving that we know that we're proving that the owner of the certificate private key knows that password. And that's how you prove that you're you. And there's no way to repeat that because you'd have to know the private key of the certificate, and only you know that, right? So again, it's really a very, very clever way of basically sending a password in a way that is not reproducible, and also proves that you know something. It proves that there's nobody in the middle basically messing up in the middle of your communication. Okay. However, Postgres does not have typical protections for passwords. I talked about this in the keynote in the morning. Postgres has a tendency to be minimal in the features that it adds. So if it can do something externally, it has a tendency to favor that external solution. So there's no real built-in capability for weak password detection, password reuse protection, or even brute force password attacks. If you need that type of protection, we're going to recommend you use a tool like LDAP or PIM or SSPI that's designed to protect from these type of cases. Okay. Yes, we could have built them into Postgres. It would have made Postgres larger. We chose to defer the problem, if that's what you're worried about, to those external tools. You may already be using LDAP anyway. So why not just use it with Postgres, right? I mean, you've already got some infrastructure anyway, which probably manages that. We're better off just allowing Postgres to use that facility than to build it in. There are some difficulties with connection pooling, but again, that's kind of a good way going at it. So we might have protected the password from being seen going back and forth. Is our job done? Maybe that's all the protection you need, but be aware that once you've authenticated, all of your queries and all of your data, if you're not using SSL, is going to be seen in clear text. So all the numbers, all the output is going to be just sent across the network. Okay? So you might have gotten the authentication protected, but you might not have protected your data. Okay? So this is vulnerable, obviously, to snooping, where somebody can watch the data coming across. Okay? Any questions? Okay. So people say, okay, I protected my passwords or my authentication method. Now I'm going to use SSL or TLS. It's the same thing. And I'm going to encrypt everything that goes across. Maybe I'll even use the AES-256. A little on the heavy side, but okay, fine. That works. We're going to send our queries with encrypted with AES-256 or some secret that we've negotiated, a shared secret for the two ends to negotiate. And my queries are going to come back basically encrypted. Right? So I think, okay, I got my authentication locked down. I've got my data locked down. I'm done. Right? I'm going to go home and just relax. Right? But no, you can't relax. Why can't you relax? It's because of this guy. This is our spoofer. Remember? So we had snooper, which is the sort of person who's always snooping and watching the data cross. But the spoofer is more complicated, more sophisticated. The spoofer pretends to be someone else, right? So how actually can that work? Well, this is the most simple spoofing problem that I can imagine. Imagine your server's down. Maybe it's in maintenance. Maybe it's offline. There's hardware problems. Who knows? So your server's offline. Okay. So your client here connects to the server, and it says, I want to connect. And your server comes back and says, I want a password. And you just send the password back. And the server says, oh, I'm sorry. We have a network problem. Come back later. Okay. So what happens? Well, the server comes back online. Mr. Spoofer has the password. So he's like, oh, I'm just going to go connect as that user. He's not even here right now. It's 2 a.m. and I'll just connect and pull all the data off. Not a good system, is it? Right? Not good. But it's very easy to do. I mean, the server's down. In fact, you can even kind of play with the sockets if you want to kind of fake it out. I mean, there's a whole bunch of weird ways you can kind of fake out a server, pretend you're the server. Here's another one. With a fake server. So here server's up, but somehow I pretend I'm the IP address of the server. Maybe I can use ARP. Any of you use ARP, like the address resolution protocol, and you say, this IP address over here. This is my MAC address, and then all of a sudden the traffic goes to this fake server instead of the real one. And password gets sent, right? Or you do this. This is even better. Here, the client never knows that it's not talking to the real server because effectively the database says, "Oh, I want to connect," and he says, "I want a password." Okay, here's the password. And what the fake server does, it sends everything to the real server. You call the queries, all the results. Real server has the client has no idea it isn't talking to the real server. It's obviously not a position you want to be in. Now, you may say, well, this is too sophisticated. Most people won't do it. It's true, but it's possible. It's possible. You shouldn't allow it, right? I mean, that's my logic. It's like, yeah, okay, it's maybe sophisticated to set up, but people set up tooling, they set up rootkits, and no matter how sophisticated it is, it takes one smart person to set it up, and then you're done, because everyone downloads it, installs it, and scoops up passwords. Any questions? Okay, so you might say, okay, so how do I fix this? I know what I do. I'm going to use SSL, right? I'm going to use SSL, and then my problems are solved, right? So here I say prefer SSL, which is the default if you turn SSL on, and the fake servers say, no, I don't support SSL, and the client just says, okay, we're back to where we were, and it just sends a non-SSL thing over there, and everything goes back and forth to the real server, and we're probably no better off than we were before. So that's the default mode for SSL, but you may say, no, I'm going to use SSL require. There's a special SSL mode in the connection string if you've never seen it, and you say SSL equal require, and you're like, oh, that's obviously got to solve one of my problems, and the database client says, I'm going to require SSL. You can't say no, and the fake server says, okay, here's SSL, and we do an SSL connection between these two, and the fake server creates an SSL connection between these two, and where are we? Have we gained anything? No, we have not. Okay, so my point is that there's this feeling, and this is what I talked about in the beginning. There's this feeling like if I just sprinkle the right magic dust on, either it's encryption or whatever, password security, whatever, it's going to fix the problem, right? But unless you really dig in and understand exactly what the threats are, you really don't. And that's why I kind of wrote this talk, because the solution appears to be really simple, but once you kind of dig into it, it's not very simple. Now, you might say, well, I use SSL with a browser, right? I mean, many of you use HTTPS, which is using SSL or TLS. But you have to realize that all of that communication over your browser, and I have it in my slides, is really using much more than SSL. It's using certificates, certificate authorities that are built into the browser. If you've ever looked in your browser, there's actually a certificate authority list of what certificate authorities it trusts. If you're going to do that, you have to do that. If that's the only way to do it right, and unfortunately, you have to do the same thing in Postgres. I'm going to show you why. Yes, sir?
Yeah, how does that work? Because the fake database server will have one of the correct certificate. Won't have the correct certificate.
Right. So I haven't really talked about certificates yet. That's my point, right? That we're turning on SSL. See, this is why I wrote this, because there's a sense that if I encrypt, I'm secure, right? And what I'm trying to get at is that Postgres gives you the tools to secure it, but if you just turn on encryption without doing the identity management, then you're really not secure. And people, unfortunately, if I don't give these type of talks, they're unfortunately going to set it up thinking, I'm secure, it's an SSL connection. Not really. Oh, I'm going to make it require. No, you're still not safe, right? So I'm trying to walk through the logic here of exactly how to do this properly, right? This is how to do it properly. Perfect setup. To do it right, you have to have some type of certificate authority that effectively allows you to verify that the server you're talking to is a legitimate server that deserves to receive the password from you, deserves to receive your queries, and return your results. Okay? So the way that typically works is you have a certificate authority who is signing a certificate for the server, okay? And then you have the root certificate of that certificate authority, not the private key of certificate authority, because nobody has that but the owner. But we have this certificate right here, okay? And over here we have the certificate and we have the private key, which goes with it. And effectively what happens here when you say verify CA, you send it to the fake server, it cannot send back a signed certificate because it doesn't have the private key of this. And the client will say, I will not connect because that certificate, you fake certificate you sent me server, that's not signed by that root certificate. Okay? And without this final step, you're not really secure just using SSL TLS. This is done internally for you when you're using a browser. On my slides, I actually have screenshots of Firefox and Chrome, and if you dig down in the little menu tabs, you can actually see trusted certificate authorities in your browser, and you'll see them all signed. All the banks will get them signed. Let's Encrypt, those of you using that, the Let's Encrypt root certificates are in the certificate store for all modern browsers. DigiCert, give me another one. VeriSign, thank you, the big ones are all out there. They're all in there, and they're validating and preventing that snooping, that spoofing problem. And we need to do the same thing here. The Postgres docs are very clear about how to basically set this up with detailed instructions, including how to set up intermediate certificates. If you go to my website and look at the blogs under security, there's a category. I know I have 650 blog entries, but you can actually look at them by category. So there's a particular category called security blogs. And it talks about how to set this up, how to use intermediate certificates, because typically you would not maybe use a root certificate, you might use an intermediate, and a certificate chain, if you're familiar with that. But the Postgres docs, when I originally started this project, were a little hazy on these issues. The instructions were not fully clear, but through the team, and I think, Peter, you might have helped me a little bit on that too, we kind of narrowed down exactly what commands work and why they work and exactly what it's doing. So I'm very comfortable. We haven't had to modify those docs in a couple years, but if you look at any modern version of Postgres, it'll be very clear the importance of this and how to set it up. Questions? Yes, sir.
So this will rely on your connection when you set the SSL mode on the client, but as a best practice, you can force Postgres does not accept any SSL connections. You can configure it in HBA, and maybe many cloud providers give you an easier option to force the SSL from database side, not rely on the connection from the client itself.
Yeah, so back in that HBA file, you can basically say SSL only, and only SSL connections will come in. What you really need, though, is and I didn't even cover this, I probably should. There's a little flag you can put in the HBA which forces the client to verify that it has a certificate signed by the certificate authority. So it verifies not only SSL, but it only allows clients which have certificates signed by this root certificate authority. I'm going to maybe add that little slide. I should have added that. It's kind of an awkward thing because it's a server setting, but.
And also some people, if you want to secure the connection, also to make sure that the client is using the SSL verify CA. So when make sure that the users use a jump host, that's all the deployments for the clients is automated. So you don't install your client and then do whatever you want. So you force them to use this mode. So to make sure that even them is using verify CA on a controlled jump host, not without like any laptop or any Mac or any whatever.
Yeah. Typically, the cleanest way to do that, I think, is to create a services file that's global, and therefore everyone is using a services file, and you manage what's in that services file, and you can make sure every line has that requirement. We have had some people who wanted us to modify libpq in a way so only see. We haven't gotten any farther. I might have a blog entry about that. I can't remember, but that's something we maybe need to still talk about. Secure, right? You would require libpq to only use this verify CA, and how do you do that? We've kind of been back and forth. I'll take a look at my blogs and see if I have one.
Also for monitoring, there is a catalog view that tell you which the secure they are using, or they are using SSL or not. Some people monitor this if for any chance there's a connection that's using
Yeah.
non-SSL, so they alarm security team so they can take action.
Yeah.
Just discover that something.
Yeah. Yeah. It's very, very, very interesting stuff. Other questions? Yeah, sure. So that's a great question. I do have a blog. I'm sorry. The question was, do you run your own certificate authority? I have a blog entry about that. The answer is yes. And it's a little, how do I say, counterintuitive. A lot of people think that, okay, if I get it from a well-known certificate authority, a public certificate authority, that's somehow more secure. But the problem is, by getting the certificate from the certificate authority, you're effectively saying that certificate authority could potentially create their own certificates that would access your database, which you probably don't want, right? Public certificate authorities are very useful when you are basically have distributed people who have no connection to your organization, okay, who you want to connect securely to your website. Makes sense. But in the case of a database, that's almost never true. And therefore, you're better off creating your own certificate authority than creating an intermediate certificate authority, which then would sign the certificates, and then have an expiry set up so that you would expire every 6 months or 6 years or whatever. If the intermediate certificate is compromised, you only put the root certificate on the clients, and therefore you can replace the intermediate certificate and the other certificate and the leaf certificates on the server. And what you typically do, and the Postgres docs are clear about this, you basically create a certificate chain on the server, and it sends the intermediate and the leaf certificate to the client. The client only needs to verify the root certificate because that doesn't change. So you see what I'm saying? You may have thousands of clients. You may only have 10, 20 server certificates, right? And you can therefore rotate those server certificates much more efficiently without having to interfere with potentially thousands of clients. Because unless this is compromised, this one remains good. You just plop, change in the intermediate. And that whole process of when does the intermediate certificate get shipped to the client was, I don't know if Peter, you remember, but it was a huge amount of research. And we even have regression tests now that run, which shows to make sure that the API that we have is properly shipping the entire chain to the client. So you don't need to have intermediates stored here. You just put the root, you leave it there. And if you want to change intermediates or leaf certificates, you just do everything on this end. And the chain goes across. Yeah, and my blog entries have a lot of gory detail about that. But I thought it was important because, again, it's in terms of management of certificates, it's actually really interesting. And I think gives you a power as an administrator that you don't really have with passwords and stuff like that. Yes, ma'am. So what's the best practice for renewing these certificates, or do they expire? So that's a great point. So what we think about passwords, right? Passwords typically, like, it's either password A or it's password B. And as soon as you change from A to B, everyone's got to change at the same time, right? Which is awkward. So what you typically do is you set your certificates for, let's say, 18 months, okay? And then 12 months in, you start rotating out these certificates, and you have some kind of monitoring, which you can query. You typically query their certificate to find the expiration date. There's a whole bunch of tools that do that. So you can have a little thing just goes out and say, where are all my certificates that are less than 6 months to expire? And you can go in and swap them out. Nobody needs to know. There's no change. The new certificate, the old certificate, they behave exactly the same. In fact, Peter, you did some work where you can effectively put in a new certificate and just reload the database. Or even, Peter, does it look the modification time? No, we decided you have to do a reload to force the server to see the new certificate because we didn't want to sort of get it while it's copying or something like that. Yeah. But again, there's been a lot of management in here about getting that to be a smooth process. Classic case is, let's suppose a certificate gets compromised. You have an employee who leaves, something like that. You can effectively just press a button, go through your your intermediates issue brand new certificates. They push them out to all these servers. Any certificate that was sitting there before is invalidated, right? And then you can have a certificate revocation list, a CRL they call it. And what you effectively do is if you have an employee who left and you don't want their certificates to be valid anymore, you put them in this CRL file, and Postgres can read those files and will no longer accept any of those certificates that maybe you know. So again, there is not only is there an expire, but you can force invalidation. Again, impossible to do really with passwords. Very simple to do with these certificates. Yes, sir.
Well, I don't want to get into the rabbit hole of shootout with another product, but competitive engine does do that and has an overlap period on passwords. So multiple passwords are accepted.
Okay.
Concurrently, so that you have some time, which you can
Right.
specify on a per user basis to update app servers. So is that
Right.
on the roadmap? Or
So the question is, have we considered the ability to have multiple active passwords with some kind of expiry time? Yeah. We have talked about it. I think there's certainly it wouldn't be hard to do. I think we have a tendency to default back to like an LDAP kind of case and say, well, let that manage it. There's no reason we couldn't do it. Peter, we've talked about it. It's never really gotten any traction, but there's nothing, no aversion to it. Am I right?
Somebody actually just talked to me about that the other day, so there seems to be some interest.
Yeah, yeah.
It's
Yeah, we can work through it, but it's not something that we couldn't do. Yeah, good point. Other questions? Yes, sir.
Based on the conversation, you are saying that even from the developer's machine to connect to the server, ideal way to use the certificate, right? So that is a more secure way.
So, okay, so are you talking about certificate authentication?
Yeah, even from the developer machine. So let's say not only from the application server, even from the multiple developers trying to connect to the database, they can connect to SSL certificate with verify certification method. So in that case, like, can we have multiple certificates? Okay, from the developers having different certificates, and the application have different certificates. That way, both certificates it can certify on the server side, or always we can have one certificate only across all, like for irrespective developer or application.
All right, let me get to that in a minute because it's kind of multiple questions there. Okay, so okay. So you have any questions about this so far? Because he's getting into a different area I didn't want to get to yet. Okay, all right. So let me talk a little bit about channel binding because I've kind of talked about this whole certificate fix problem, right? How do we fix the problem of these certificates? Okay, of preventing the spoofing, right? You can see how that would work. And I alluded earlier, the channel binding, as the SCRAM with channel binding, has a similar capability. I just want to show it to you here. Effectively, the way channel binding works is it gets the requests, needs SCRAM. It actually asks for channel binding. And what happens is that the shared secret, well, basically, the certificate hash, which is basically each end of an SSL TLS connection has a certificate, okay? So what it does is it takes the hash of the certificate and it mixes it with the password and sends it to the other side. And what that does, when you think of the word channel binding, it's taking the TLS channel and it's binding it to the password, right? It's taking the shared secret that the two certificates have negotiated, binding it, mixing it with the password, and sending it back and forth to prove that the person on the other end knows the password. Instead of you just blindly sending a password, you require the server to tell you, before I send you a password, you tell me you know the password. You don't send the password, but you can prove that you know the password because the shared secret that we used or the hash that you've used proves that you know the secret. And when that happens, you prevent that man-in-the-middle attack, okay, from happening. So if you don't like certificates, this channel binding capability actually fixes that problem for you, okay? Now, I think this is what the gentleman here was talking about. And it's something else I want to And Magnus loves this thing, so just whatever. We can tell him how much he loves it. I love it too, so there you go. We've talked about sending passwords back and forth, right? But passwords, are, as I said to the woman here, they're awkward. You change the password, and all of a sudden the old one goes away. And okay, maybe we can have two passwords, and we can have both of them active at the same time. Yeah, we can kind of do that, but then you got this awkwardness that the two passwords are active, and then once everyone's using the new password, you really should shut off the old password because it's kind of a vulnerability, right? And how do you know when to shut them off? And so one cool thing about Postgres is you can actually use certificates for authentication on the client. So basically, the database server says, I want an SSL certificate that is signed by the root, signed by one of my trusted root certificates. And effectively, the client will send back an SSL certificate that is signed by one of the trusted certificate authorities, and that proves that this is a valid client. So no need even for passwords, okay? Can't replay it because these certificates are huge numbers, okay? You can't randomly do it. Plus, this is actually getting back to, I think, what you said, you can rotate these passwords as much as you want because the old certificate works, the new certificate works. You just plop in a new certificate, right? And then if you want another one, you do it again, right? And you can specify the length of how long that certificate's valid. So by definition, within 6 months, all of the old certificates are invalid by definition. So when you ship the certificate, it only is good for 6 months. So you don't have to go back and turn it off. You know in 6 months it'll be no good. If you want to revoke it, you have this certificate revocation list. You put that certificate in the CRL. Postgres understands those files, and it will actually prevent it from being used from there forward instead of waiting 6 months, okay? But this is a fantastic way of doing authentication, far superior to passwords, I think, and easier to manage. I do have a blog entry about this, and the ability to rotate them out, I think, is key. There is no one certificate. Any certificate signed by that certificate authority is valid. You don't have to have one used by everybody. You would never do that, frankly. You would create one for each individual, each service, each machine, and have them automatically expiring. Of course, you do have to go and reinstall those, but that's part of the beauty of it because you don't have passwords sitting around being reused for years and years as employees leave and so forth. Questions? So the certificate is public. I can download a certificate for IBM tomorrow, anybody, Google. The certificate itself is public. What isn't public is the private key that matches the certificate, okay? So those private keys have to be kept, and I'm going to show you in a minute how they can be kept, okay? Other questions? Okay. So let's talk about, let's talk about data encryption to avoid theft. Hold on, okay. So I'm going to get to it in a minute. So one thing that I want to kind of highlight here is that if you are storing your data on some type of removable media, that media has your data on it. So be careful. I remember being young in my in 1993 or something, wondering why there's a box of backup tapes just sitting in the server room. Like, why are they just in the corner? And I'm like, why are they there, Herb? I mean, like, he's like, well, if somebody picks up a tape, they just walk out the building, they got all our data. I'm like, oh, gee, I never thought of that. So from then on, I was like, okay. So again, make sure your media is secure because that's another vulnerability you could potentially have. One capability that we have, and Peter Eisentraut, you're working on an improved version of this soon, I think, is the ability to do column encryption. So we have something called PGCrypto, which allows you to encrypt a column. I have a bunch of blog entries about this. There's PGSodium is a great solution for that, which allows you to kind of do per column encryption in Postgres. A little different than we've talked about before, but again, if you need a single column encrypted, that is an excellent solution. One of the gentlemen asked, where do you store the key? If you have a secret, where do you put it? Well, one option is to put the key on the server. Maybe good, maybe bad. The problem is your key is with the database, so if they take the database, right? Another one is to put it in some type of cryptographic server, like a secure vault or something, and pass your queries through there. Another option, I think a cleaner option, is to put the key on the client. So therefore, the data is encrypted going across and back. So the data over here is always kind of well, in this case, we're passing the key. This is a better option where we're actually encrypting as we send over and then back again. So this server could be stolen, and there's no way to access the data because you don't have the key. But obviously, the problem here is the client has the key. So what you can actually put it on a hardware device. I would recommend a PIV device, if you're familiar, a CAC. YubiKey makes them. Google makes them. A bunch of different hardware vendors make them. I have a separate slide deck about cryptographic hardware. The beauty of putting the key on a hardware device is there's no way to extract the key from the device. If you put a key on a USB stick, somebody can copy the USB stick. You put a key in a hardware security device, even the manufacturer cannot get the key out of the device. You can encrypt and decrypt using the key, using an API to the CAC, to the hardware device, but you can't just extract it out and copy it. And that, I think, is the dramatic change between just storing it in the file system or storing it in a USB device, storing it in a PIV device or a CAC, YubiKey, Google Authenticator, whatever type of device. Okay. And that is all I wanted to say. I do have about a minute left, so I'd be happy to take any additional questions that people have. The bad news is that people already queued up for lunch. So I was hoping to get done early, and we'd be the first ones out there because we're right there. And I failed, and I'm sorry about that. Any questions? Yes, sir.
For the hardware keys, would you have multiple keys as a backup strategy?
So with the keys, I would use multiple keys for a backup strategy.
How would you back up?
So I actually covered that in one of my blog entries and in the slides. What I typically recommend is not to create the key on the hardware device, but to actually create the public-private key on a USB stick, okay? Copy the public-private key into the hardware device, take the USB stick out, put it in a bank vault. Because that way, if you lose a USB stick, you get another USB stick, you put the USB key in, you copy it to a new USB stick, and then you put it back in the vault. That's, I think, the cleanest. You can create the keys directly on the hardware cryptographic devices, but as I said before, there's no way to get it out. There's no way to back it up. It's just in there. And that may be okay if you're doing things like signing, or there's a couple ways where it actually doesn't matter if you lose the key, but in the case of encryption, it absolutely does matter if you lose the key. So you'd want to probably generate it off device, make a physical backup of it, put it in a secure location, and then store that on a hardware device. Yeah.
Can I have a comment on this?
Please.
It also depends on the industry. So for the financial industries, you have PCI regulation. So you have to follow the PCI recommendation, like how to store it, how to use it. So it's not like you can use it a specific way. There's a standard how to store the keys. And even if you're in cloud, how to use this in the cloud, if you need private or on-premise data centers, there's devices that you can use it and you request a key. And so it depends on the industry also and the regulation for each industry, how to, especially for the keys.
Great. Well, thank you, everybody. Oh, I'm sorry, yes.
I know you haven't covered TDE, but is this something coming in near future?
So the question is about TDE. It is something that I've been working on for about 5 years. I don't know if we're going to get it in 16 or not. We have some patches, but I still have some convincing to do, and we're continuing to work on it. I do think it's important, but it's not a universal understanding in the community yet. So thank you very much. Appreciate your time. Have a great lunch.